Welcome to Analog Layouts. In this video lecture, we are going to discuss what is the basic needs and what is the basic important steps and rules we are going to follow in the memory layout design, because memory layout design is completely different from analog. So here we are going to discuss what is memory layout, how the memory layout structure will be there, how to effectively implement the memory layout structure in the layout. Let's start the video. This topic is a very interesting topic. So we are going to discuss about how to do the SRAM layout and what is the difference between the analog layout and the memory layout, because the RAM will come under the category of memory. So it's a type of RAM. Okay, static RAM is a SRAM. So it's a type of memory which will be used in the memory circuits. Analog circuits and memory circuits are completely different approaches, and they have a completely different analogy to do the layout. So now our part, today we are going to discuss in this lecture, we have a SRAM cluster. So this one is our, for example, this is my block A, and we have additionally we have one more block we have. So that is our adder architecture. So this is considerably, I am considering this as a block B. So now initially I am going to focus only about the SRAM cluster. So after this we will be focusing about what is the layout structure, how would be the layout for the adder architecture design. So we need to observe how many types of input pins are present in the digital circuits. That's what generally digital circuits will work. Analog circuits will have very less number of input signals compared to digital. Digital always having more number of pins as a input and output. So now in this SRAM cluster, usually we have two powers, like we have a VDD and VSS. So it's a general power we are using for the device. So then we have a output signal. Our output signal here, we were assigning it a name of RBL. So RBL is my output signal. In my output signal, I'm almost getting 160 signals. So here in the input pin, they have mentioned something called 0:159. That means the total number of pins are 160 pins. Then 160 pins are output. On top of that, we have so many input signals which will be as an input as a SRAM. As an input, I'm giving my RWL signal and as well as my WL signal. So both are having 128 signals. Okay, so these are all digital signals. So we need to carefully route this digital signal. So these are all the very much important constraints and criteria for memory block. So then additionally, we have another two more input signal, that is BL and BLB. Okay, these are all just 10 pins. So comparatively, it is very less number of pins. Then we have one more input signal, that is called our PC. PC is a 16 input signal. So combination of everything here. So we have a WL signal, we have a RWL signal, we have a PC signal. Then this is our output, what we mentioned, 160 signals. Then on top of that, these signals also we have. See, technically as a layout guy, we don't wanted to more explore and dive about what kind of pins are there, either what is the functionality of this pin, what these pins are doing. So really we don't want to explore more about these circuits, because that will belongs to the circuit design engineers. So now as a layout person, we need to arrange the SRAM cluster. Okay, based on some criteria. The first important things in the SRAM cluster, we don't want to waste even a small area in the area. Okay, small area in the layout. So RAMs are very much compact and tightly routed devices, and not like analog. So we don't waste more amount of area in the layout. So even a small 1 micrometer or 0.5 micrometer area wastage in the RAM circuit will lead a major consequences in the area, in the overall area distribution. So now our ultimate goal is, like, first, we don't want to waste any area. Then routing, all the routing should be done on top of the device itself, that should not be go outside of the device. Okay, anyway, at this point of time these topics are very difficult to understand, but when we started the layout we can able to easily understand what I mean to say here. So all the routings including power signals and about this input signal, output signal, see almost we have more than 500 to 600 signals we have here, right? So all the signals we have to route only on top of the device. There is no dedicated place for signal routing in the memories. Okay, in the subblock level, maybe in the top level, all the signals should be routed on top of the device itself. All are digital signals, so need not to worry about your EM and IR calculation here. Anyway, IR is the main problem, but at this point of time we don't want to calculate EM and IR. The minimum metal width are 0.01 or 0.15 is enough, depends on the technology. Again, it's subjected to the technology and node. Then again, all the routing should be routed on top of the device itself. So this is the overall scenario about our layout and overall the circuit description about the layout. Based on the circuit we need to plan our routing. So remember one thing in the memory layout, in case if I am assigning my memory layout like a square, okay, for example I am assigning like a square, the main condition I should not route any signals outside of the block. Okay, so that's the main intention. So first we need to assign two signals for the power. We have a VDD and VSS, so consider that two nets has to be flow inside the block itself for power. So one will go to VDD and another will go to VSS, so two signals are common. Then again, inside the subblock level, how many pins we have, based on the pins all the routing should be kept inside the block itself. See, for example, now I have my output, I have my input 1 and input 2, and as soon as 3 4 5, then totally 6 plus 7, so totally I have 7 nets. So within this given area, so this, consider that this is my given area, within that given area all the 7 routing should be routed parallelly. Okay, in such a way that we need to design our memory block. No routings are allowed outside of the memory block. For example, outside of the memory block, maybe outside of the PR boundary here, in case if I am assigning some metal for power or maybe some other net, so this is strictly not allowed in the memory. So everything should be maintained inside the block itself, everything should be routed inside the block itself, including power routing, signal routing, everything. Sometimes there will be a row and sometimes there will be a read write signal, there will be so many signals, but all the signals should be routed inside of the block itself. Okay, this is the first main important things in the memory layout. No routing should go outside of the layout. Let's we see how the design of the circuits are present in our layout. So as per the previous diagram, this is our SRAM cluster. So now I need to enable the net highlight option so that easily we can able to understand the signal flow graph in the blocks. So now here I have 128 signals. Okay, these 128 signals does not go into any other blocks in my level. Okay, these are all only input pins. And then again, this RWL signal is also 128 signal. Even this RWL signal is not going to any other blocks. Okay, so what I mean to say, it's not going to any other blocks. See, for example, now opposite side, right hand side, I am coming to this signal, that is RBL. My RBL signal is not just output signal, and also my RBL signal is the input signal of my adder architecture. See, the pins are going from my SRAM cluster to adder architecture. So this routings are very critical in terms of layout. Okay, the signals which is not going to anywhere in the subblock level. So these pins are, we can easily able to keep the pins and the placement of the routing, we can keep it anywhere in the layout. But based on this output signal, okay, whatever the signals are coming from the SRAM cluster, which is 160 signals, so these 160 signals is the input signal for this adder architecture single column display. Okay, so this adder architecture block routing has to be follow my SRAM cluster. In case if you are doing it first SRAM cluster, the SRAM cluster is the first layout, then followed by the SRAM cluster. If I am going to do the architecture of the single column, I need to maintain whatever the routing style I have followed here, the same based on the SRAM cluster, my adder architecture has to be designed. If not, the case number 2, in case if I am doing my adder architecture as the first layout, so after followed by the adder architecture diagram, if I want to follow my SRAM cluster, then I need to follow the adder architecture diagram layout routing methods into the SRAM cluster. So that's how our internal structures has to be planned. Okay, layout has to be planned. But other than that, we have so many unwanted signals here, like which is not a shared signals. signals. Like for example, RBL signal. Other than RBL signal, there is something called select and reset signal, clock signal. So these are all only input pins. So these pins we can keep it anywhere in the layout. But the signal which is common to the SRAM, that has to be carefully routed. Okay, then again see here, this SRAM cluster is the main subblock. Okay, it's a subblock of my top level, but it's a main level, it's a top level in my level. Okay, so now in case if I'm going to inside this block, see inside this block I have something called 80 RAM cells. Okay, this is the individual RAM cells. So here in the schematic again we have a W signal, read write signal, and then something called BL signal and BLB signal, RBL signal. So all the signals are like the common signal which we have already discussed in the one more T+1 level, that is our previous top level block. Now what is this actually? So I0 is iterating for 10 times, that means 0:1, that means the blocks are iterating for 10 times in the top level. So once you completed the sub block level, the sub block will be repetitively, they will keep it for the 10 iterations in the block. So 10 times the block will be repeatedly the blocks will come. Okay, same way here I have multiple RAM structure. This is just an example of SRAM. So totally here I have 1 2 3 4 5 6 7 and 8. So 8 multiplied by 10, so totally, okay, 80 sub blocks are going to fit in this overall top level. Okay, this is my one more level, T-1 level. So here overall 80 blocks are going to sit inside this level. Let's we explore what is inside the individual block level layout. So if I go to the inside of the block, say this is my final layout, which is my T level. Okay, T level in the sense this is my base level. So first I need to arrange the layout for this particular schematic. In this particular schematic, first I need to fix the aspect ratio. Most of the time the layout aspect ratio should be in the square or should be in the rectangular. We don't want to waste any area in the memory layout, that's the main concern. Then again, whatever the signals are there here inside, not only in the sub block level, in the top level also we have to consider. Based on the entire hierarchy we need to assign the sub block level. Okay, so anyway at this point of time this will be very difficult to understand because it's a very theoretically we are approaching the layout. Practically when we are starting approaching the layout, this concepts would be very much easy to understand for you guys. So now we have a BL signal. BL signal is our input signal and VDD VSS is the power, and as well as we have a WL and then RWL and RDL and BLB. So these are all the pin signals. So let's we start the layout. How to do this layout as a memory point of view? It's not completely analog, right? It's a pure memory. In this video lecture we have discussed what is the criteria for memory circuit and how would be the memory circuits, then what is the important criteria for the memory circuits, and how to plan the routing signals and power routing signal and all the routing signals. Just theoretically we have discussed about in this block. In my consecutive videos we will be discussing about how the exact memory layout will be there and what criteria, whatever we have followed in this session, in this video, how we are going to implement these rules and regulations and whatever what is the steps and everything we are going implemented in the circuit and layout, we'll discuss in our next video. I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel and don't forget to click the bell button.